Okay, for the example in class, we start with the displacement graph versus time. We want a velocity and an acceleration graph. First, let's think about what's happening. Here I am. This is like 0 meters, 10 meters. Okay, in time, go. Oh, in 1 second I'm here. In 2 seconds I'm here. In 3 seconds I'm here. So I'm just staying here now. Right? 6 seconds, 7 seconds. So what I'm doing is I'm moving upward, up to 10, slowing down, stopping, coming back. Alright, let's get a velocity graph of this. The velocity is equal to the time rate of change of displacement. It's the slope of that graph. So here I see the slope is positive, positive, I draw this positive, but no, wait, I have a constant positive slope, I have a constant positive velocity for the first 2 seconds. What is that? Oh, it's about 10 meters in 2 seconds, or about 5 meters per second. So I can label this 5 meters per second. Now, here, there's no slope. Oh, because I'm just sitting there, means yes, for this whole time, there's no velocity. Now, how do I go from 5 meters per second to 0? I can see, oh, here the slope is 5 meters per second, maybe 4, 3, 2, 1. Over this period of time, the velocity drops from here to here. Okay? Now right here I'm moving backwards, I have a negative velocity, and again, that slope is constant, but I move 10 meters in 1 second, so it's going to be a negative 5, 10, all the way down here. It will be about negative 10 meters per second. Okay, now how do I make that transition? I go right from 0 to negative 10 meters per second. If I want to make this a well-behaved function, I say, okay, there's got to be some little change in there, and I connect this. Now, after here, do I go back to 0? I don't know. I didn't tell you what this does. Okay, so how do we go from velocity to acceleration? Well, acceleration is the time rate of change of velocity. It's the slope of this graph. I can see I have constant velocity here. The acceleration is 0 for this period of time. I have constant velocity, constant 0 velocity right here, so the acceleration is negative. I have constant negative 10 meters per second in here, or so it looks, then the acceleration is 0. Now it's these transitions that are interesting. You can see I go from 5 meters per second down to 0. Here we have a very negative acceleration, and so I can draw something that will look like this. About what is the slope of this line? The change in velocity is negative 5 meters per second, and this takes place in about half a second. So 0.5 seconds, that's 10 meters per second squared. Alright? So this is negative 10 meters per second squared, so that's an acceleration of about a gravity. I feel it every time I jump off a cliff or a diving board, I feel that acceleration. It's a lot of acceleration. Here, the story is not so kind to me, right? Because I'm getting a change of velocity of negative 10 meters per second. And what's the time period? Well, it's damn small. How small? I don't know. Let's just call epsilon. Means negative, very, very big acceleration. Okay, so what's happening here, I get this negative impulse in just 1 moment. Right? So the slope of this line is really huge. So the acceleration is really big. Why is that a problem? Because force is equal to mass times acceleration. I get a huge force. So essentially what's happening, right? I'm running forward, right? I'm running forward. I slow down, I come to a stop, and then I get this instantaneous change of velocity. Someone hits me with a truck. Boom! And then after that I'm moving constant speed, but it doesn't matter, I'm dead. So we ask, how do you want to bring me to rest? And so we're moving at a constant velocity, about 10 meters per second, and I show here how you can bring me to rest peacefully over a short period of time. So what's happening is, so we see the velocity go from negative 10 meters per second down to 0 over this period of time, which requires a positive impulse right here, and some acceleration that is big, but not really big. So you see, here I'm at rest, and then moving 10 meters per second, and then at rest. I accelerate to 10 meters per second in a really short time, requiring a huge acceleration, and then I get the same impulse to stop over a longer period of time, so the acceleration is less. So that's a nice way to bring me to rest, but I'm already dead from how I got hit here, so it doesn't matter.